Your race car is flying down the track at 200 miles per hour when suddenly the driver slams on the brakes. In an instant, the seatbelt digs into his chest as he's thrown forward. But here's the puzzle. Why does slowing down feel exactly like speeding up? Today, we're going to decode the mystery of acceleration. You'll see why acceleration isn't always about going faster. You'll learn how it can even oppose velocity, and you'll master how to read acceleration from graphs. By the end, you'll understand the true meaning of change in motion. Our goal is clear: to describe average velocity and acceleration, with special focus on what's really happening when objects are accelerating. So let's pin this down.
Quick pause. You're watching this because it was created on EulaIQ. EulaIQ instantly transforms your textbooks, PDFs, or notes into explainer videos, podcasts, or practice questions. Imagine turning your study materials into learning content you actually enjoy. That's what EulaIQ does. And you can try it now for free at EulaIQ.com.
Acceleration is simply the rate of change of velocity. We write it as A equals delta V over delta T, change in velocity divided by the change in time. And here's the crucial insight most people miss. Acceleration doesn't just mean speeding up. It means any change in velocity, whether you're speeding up, slowing down, or changing direction. That means even our race car braking hard was experiencing large acceleration. Like velocity, acceleration is a vector. It has both a magnitude and a direction. The magnitude tells us how quickly the velocity is changing, while the direction tells us which way the velocity vector is shifting. And here's where it gets interesting. Acceleration and velocity don't need to point the same way. If they do, the object speeds up. If they're opposite, the object slows down. That's exactly what was happening with our race car mystery. Let's make this concrete. Imagine a car going from 10 meters per second to 20 meters per second in just 2 seconds. The change in velocity is 10, divided by 2 seconds, giving 5 meters per second squared. Those units matter, meters per second per second. That tells us how much velocity changes with every passing second. But now comes a common point of confusion: negative acceleration. Students often assume it means slowing down, but not so. Negative acceleration just means acceleration in the negative direction. Picture a car backing up and pressing the gas. Its velocity points negative, its acceleration points negative. The car speeds up while reversing. Negative acceleration, but increasing speed. Now let's go one step further. Just as with velocity, we can talk about average acceleration versus instantaneous acceleration. Average acceleration is over a time interval. Instantaneous acceleration is at a specific moment. Mathematically, it's the limit of average acceleration as the interval shrinks to 0. On a velocity time graph, instantaneous acceleration is the slope of the tangent line. If the graph is a straight line, acceleration is constant. The instantaneous and average values match everywhere. But if the graph curves, acceleration itself is changing. Curving upward means acceleration is increasing. Curving downward means it's decreasing. The slope, positive or negative, tells you the direction. So how do you feel this in everyday life? Think about an elevator. When it starts moving upward, you feel heavier, upward acceleration. When it starts downward, you feel lighter, downward acceleration. Your phone even detects acceleration constantly with its accelerometer. That's how it knows when you've rotated the screen. So when exactly is something accelerating? Whenever the magnitude or the direction of velocity changes. A car speeding up in a straight line is accelerating, a car slowing down is accelerating, and even a car moving at constant speed around a curve is accelerating, because its velocity direction keeps changing. Remember, changing velocity equals acceleration, no matter what. Let's tie it all together. Acceleration is the rate of change of velocity. It's a vector with both magnitude and direction. Negative acceleration doesn't always mean slowing down. An object accelerates when its speed changes, its direction changes, or both. And graphs, especially velocity time graphs, reveal acceleration through their slopes. In the next video, we'll push further into motion diagrams and kinematic equations, tools that let us predict future motion from present conditions. Because motion is never just about changing position, it's about the dance between velocity, acceleration, and time. And the best part? Acceleration is everywhere around us, in elevators, in smartphones, in race cars. Now, you'll never see those everyday motions the same way.
Before you go, here's the best part. This video wasn't handmade. I just uploaded a PDF and EulaIQ turned it into this explainer automatically. You can do the same with your own notes or textbooks, and in seconds get a clear video, an audio lesson, even quizzes. Start for free today at EulaIQ.com and make studying effortless.